Okay, we're going to be solving some more trig equations today. But this time, they're going to look a little bit different from what we did last week, because instead of just having a theta right there, you'll notice that it says there's 2 theta. And so what you want to do is you want to kind of think to yourself, just solve as if it just said tangent of theta. You want to just kind of pretend for a moment that that just says theta. What if we were just solving tangent of theta equals -1? So you want to think to yourself, okay, here's my little grid. If tangent is negative, I'm going to be in the second and the fourth quadrant. I'm going to draw a little sketch of that. That's going to be at 3 pi over 4 or 7 pi over 4. Again, you'll notice that as we get from the one angle to the other one, we can just add pi. And so we can just write that as one statement, and our theta here would be equal to 3 pi over 4 plus pi k. But we're not actually trying to solve for theta. We're trying to solve for 2 theta. So let's come back over here and say, okay, well, I have my theta that I kind of pretended was theta is actually equal to 2 theta. So what's actually equal here is that 2 theta is equal to 3 pi over 4 plus pi k. And then I want to think of how can I change this so that I just have theta. I want to get rid of that 2. So I could multiply by 2, but a lot of the time we're going to be dealing with fractions here. And so it's going to be a little easier. Instead of dividing by 2, we're going to multiply by the reciprocal, which is 1 over 2. So 1 over 2 times 2, that's going to cancel, and that's going to just leave me with theta. That's what I want. And here I've got 1/2, so I'm going to multiply by both of those things. That's going to give me 3 pi over 8 plus pi over 2. Okay. That's my general solution. Oftentimes, you might actually be asked to list some of those solutions. So maybe we want to list the first 6 positive solutions. So the first one would be 3 pi over 8. And then we want to add pi over 2. Well, it's helpful probably to get a common denominator here so that we can think of pi over 2 as being equivalent to 4 pi over 8. And so we can add 4 pi over 8 is going to be 7 pi over 8. And then we'll add another one. We'll get 11 pi over 8. And then we'll add another one, 15 pi over 8. And add another one. And another one, and we could keep going until whatever it is we're trying to do. If we were asked to find all of the angles between 0 and 2 pi, then we would think about, well, what is 2 pi? 2 pi is 16 pi over 8. So it would really just be those first 4, and we would stop right there. So depending on what you're trying to do, sometimes you're going to want to write the general solution. Sometimes you want the first 6, maybe you want the first 8. Maybe you just want the first ones that are going from 0 to 2 pi. So let's see what that looks like graphically. I've graphed the left-hand side of my equation is my red curve here, and the right side is -1. And so if we look to see where they intersect here, we can see there's 3 pi over 8, 7 pi over 8, 11 pi over 8, 15 pi over 8, 19 pi over 8, and 23 pi over 8. There are my first 6 solutions. All right, let's take a look at the next one. We're going to start with our equation that says 2 times sine of theta over 3 equals -√3. So the first thing that you want to do is similar to what we were doing last time. You first want to just get this sine by itself. So I'm going to divide both sides by 2. And now I get an equation that says sine of theta over 3 equals negative root 3 over 2. And so then I want to do something similar to what I did in the first problem. I want to think, okay, well, what if this was just a theta there? What if I had sine of theta equals negative root 3 over 2? So I'm going to draw a sketch. If sine is negative, it's going to be in the third and the fourth quadrant. Root 3 over 2 is the longer side, so it's going to be one of the steep angles. And so this is going to be 4 pi over 3 or 5 pi over 3. And then we're going to repeat. If we spin around either clockwise or counterclockwise, it would repeat itself. So we're going to get two solutions here. We've got 4 pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. So once we've done that kind of little side calculation, I'm going to come back over here and I'm going to see what's going to happen. And because I've got two solutions, I'm going to split this into two different things. The first thing I'm going to say is, okay, this was what my theta was, but actually theta is not theta. It's inside there is actually theta over 3. And so theta over 3 could be 4 pi over 3 plus 2 pi k. Or theta over 3 could be 5 pi over 3 plus 2 pi k. And then once you've set up those two separate equations, now you're going to try and get theta by itself. If theta is divided by 3, if I want to solve it, I'm going to multiply by 3. So those two 3's would cancel. I'm going to get theta equals, this 3 is going to get distributed to both of those things. So if I do 3 times 4 pi over 3, those two 3's would cancel, and that's just going to give me 4 pi, plus 3 times 2 pi is going to be 6 pi k. I'm going to do a similar thing to this side. And so here I would get theta equals 5 pi plus 6 pi k. Again, I'm just distributing that 3 to both of them. So this is my general solution. And then if I wanted to write my first 6 positive solutions, the first one would be 4 pi. The second one would be 5 pi. And then I'm going to alternate here. And my next one is going to be 4 pi plus 6 pi, which would be 10 pi. My next one, I'm going to take 5 pi plus 6 pi, that would be 11 pi. And then I'm going to do the same thing again. I'm going to add 16 pi, and then I'm going to add 6 pi to 11 pi, and I will get 17 pi. So those would be my first 6 positive solutions. If you look at them graphically, this one looks a little different. You can see there that the period of the sine function, since this was divided by 3 here, it's actually stretched it out to be 6 times. I mean, sorry, not 6 times, 3 times as wide. And so our period is now 6 pi. And so if I graph that, you can see my first intersection point, there's 4 pi, 5 pi, 10 pi, 11 pi, 16 pi, and 17 pi, which is exactly what we got when we just did it algebraically. All right, let's take a look at another one. So we're going to start with an equation that says the square root of 3 times tangent theta minus pi over 6 equals 1. We're going to start by getting the tangent by itself. So we're going to divide by the square root of 3, and we would get tangent of theta minus pi over 6 is equal to 1 over root 3. We could then rationalize that. And we're going to get that the tangent is equal to root 3 over 3. And then we want to think again what if this was just a theta? What if I had tangent of theta equals root 3 over 3? What would that be? If the tangent's positive, we're going to be in the first and the third quadrant. Since it's root 3 over 3, the inverse of root 3 over 3 is pi over 6. And so it's going to be pi over 6 and 7 pi over 6. And so my theta here, my big giant purple theta would be equal to pi over 6. And then again, we're just going from pi over 6 to 7 pi over 6. We just need to add pi. So I can just write plus pi k. I don't need to write it out twice. And so then I'm going to, once I've figured that whole piece out, this is exactly what we were just doing last week. Now I'm going to come over here and kind of add this piece in and say, okay, well, theta, the purple theta is equal to pi over 6 plus pi k, but I don't actually have that purple theta. What I really have is theta minus pi over 6. That's what that's actually equal to. And that's equal to, I figured out that that was equal to pi over 6 plus pi k. So now I want to think, okay, what do I need to do to get that theta by itself? I need to get rid of this minus pi over 6, so I can add pi over 6 here. When I do this, I'm only adding pi over 6 to this term. I'm not going to add it to that one because it's not a like term. I'm just going to add it one time. And so then I'm going to get theta equals pi over 6 plus pi over 6 is 2 pi over 6 plus pi k, and I could simplify that to be pi over 3 plus pi k. So this would be my general solution. And then if I wanted to write my first 6 positive ones, I could go pi over 3. Now I'm going to add pi or 3 pi over 3. So that's going to be 4 pi over 3, 7 pi over 3, 10 pi over 3, 13 pi over 3, and I'm going to do one more, 16 pi over 3. Again, if we wanted to just do the first, all of the solutions between 0 and 2 pi, I would have just stopped right there. It would have just been those two. So read carefully what the question is asking you as to how many solutions you want. If we look at this one graphically, this is what it's going to look like. Oh boy, okay, I'm going to, let me zoom back to the way it was. And so we can see our first solution here is pi over 3, 4 pi over 3, 7 pi over 3, 10 pi over 3, 13 pi over 3, and 16 pi over 3. All right, last one. We're going to have an equation that says 2 times cosine, and this one's going to have lots of stuff going on the inside. We've got theta over 3 minus pi over 2 equals -1. So start by getting the cosine by itself. I'm going to just divide both sides by 2. We get cosine of theta over 3 minus pi over 2 equals -1/2. And then we want to kind of think, okay, here's this giant theta here. What if I just had cosine of theta equals -1/2? Let's think about what that would be. The cosine is negative, so we're going to be in the second or the third quadrants. The cosine is the x, and the x is the short side here, which is 1/2. So it's going to be the steep angle, 2 pi over 3 and 4 pi over 3. So I'm going to write 2 solutions here. My theta that I just found, this big theta, is equal to 2 pi over 3 plus 2 pi k. This one's going to be 4 pi over 3 plus 2 pi k. So since I have 2 of them here, I'm going to take this and I'm going to split it into 2 possible solutions. So whatever's inside my big theta, my parentheses there, I'm going to have theta over 3 minus pi over 2 equals 2 pi over 3 plus 2 pi k. And my other one is theta over 3 minus pi over 2 equals 4 pi over 3 plus 2 pi k. Now you're going to solve each of these equations. So this one here, I'm going to add pi over 2. And I would get theta over 3 equals, I'm going to need a common denominator. So there's a lot going on in this problem. To get a common denominator, I'm going to multiply this one by 2 over 2 and this one by 3 over 3. So this is going to end up giving me 4 over 6 plus 3 over 6. That's going to give me 7 over 6 plus 2 pi k. And then once I've done that part, now I need to get rid of this 3. So I'm going to multiply everything by 3. And I would get 7 pi over 6 times 3. I could think of that as being 3 over 1. And so the 3 would cancel out with the 6. That's going to give me 7 pi over 2. Plus 3 times 2 pi k would give me 6 pi k. And then you would do the same thing with the other one. Go ahead and see if you can figure out how to finish that one, and then write your first 6 solutions, and I will post the completed key in Canvas so that you can check it when you are done.